Astronomers once dreamed that if a visitor from another star system flew in, we could look at the matter that was forming in an alien sun. In 2017, it happened to Oumuamua, in 2019 to 2I Borisov. But both guests raced so fast that the scientists had to literally snatch crumbs of information from them. This year, it's like the universe said, "Okay, you'll catch another chance." And it appeared in the sky, Comet 3I Atlas. How they found the alien comet. This July, Chile's Automatic Atlas System, a telescope that's supposed to search for dangerous killer asteroids, spotted a weak point creeping across the sky not quite like everyone else. The first calculations of the orbit showed a strange thing. The trajectory was not a closed ellipse. That was hyperbole, the signature of an interstellar wanderer who flew in from the outside and would never return. The object was named C-2025N1 Atlas, and when it became clear that it was not gravitationally bound to the Sun, it was given the status of a third interstellar object, 3I Atlas. The news spread all over the world. Astronomers are literally in a race to see who can point their telescopes at the comet first, from Earth, from orbit, and even from other planets. Everyone understood that this was a one-time chance. A comet would fly through the inner solar system and go into interstellar darkness for billions of years. Unlike in the days of Oumuamua, humanity now has a whole zoo of space observatories at its fingertips. And almost everyone who could went hunting for 3I Atlas. Hubble was the first of the orbiting telescopes to take a closer look at the comet. He confirmed that a coma was forming around the nucleus, a cloud of gas and dust. Then James Webb connected. His infrared eyes saw something that is not visible in a conventional optical telescope. A short time later, other missions appeared on the list of observers. MAVEN orbiting Mars, the SOHO Solar Observatory, the Punch and Stereo spacecraft, and ground-based telescopes around the planet. The view from Mars proved especially important, with Europe's ExoMars TGO orbiter looking at the comet from the other side of the solar system. This gave astronomers a second geometric base, and 3I Atlas's orbit was refined with striking accuracy. It became clear how close it would come to Mars, to the Sun, and to Earth, and when. The most striking discoveries began when the JWST stepped in. His NIR-SPEC spectrograph broke down the comet's light into its component wavelengths, how gas from another star system was brought to the lab. It turned out that 3I Atlas is almost a chimney for carbon dioxide. In her coma, there was much more CO2 than water. The ratio of CO2 and H2O of about 8:1 is one of the highest among all known comets. This is not a small detail, but a direct allusion to the conditions where this object formed. In the spectrums, they found carbon dioxide is the main engine of activity, water and traces of its decay in the form of OH, carbon monoxide, rarer molecules such as OCS, traces of ice and dust with a reddish tinge in the reflected light. That a comet is so rich in CO2 says two things. Or it formed very far from its home star, at the boundary where CO2 can freeze into ice. Or its outer layers have been irradiated for a long time by cosmic rays, fast particles flying through the galaxy that can turn CO into CO2 and create a dark organic crust on the surface. At least 2 independent studies show just that. The outer layer of the 3I Atlas core was probably baked in the rain of galactic cosmic rays for a long time, and we now see mostly this processed material in the coma, not virgin primordial ice. Another surprise. 3I Atlas water showed up earlier than it usually does for comets. The Swift Observatory saw an ultraviolet signature of hydroxyl OH, a product of the decay of water molecules, when the comet was further than 3 astronomical units from the Sun, that is, beyond the orbit of Mars. For ordinary comets at these distances, water ice is usually still silent. It simply does not have enough heat to activate. Measurements showed a fairly high rate of water emission, tens of kilograms per second, and hinted that it might not be a small crack at the surface that is active, but a significant fraction of the entire area of the core. It is estimated that more than 20% of the surface may be involved in emissions, a bit high compared to the averages for comets in our system, where individual sites are usually active. The scientists suggested that large ice grains also play a role, which are ejected outward and continue to evaporate already in a coma, feeding a cloud of water vapor around the core. Another set of observations, polarimetry, measurements of how light is scattered on dust particles, showed that 3I Atlas is not like any of the previously studied comets at all. It was found to have deep negative polarization at small phase angles. Roughly speaking, with a certain lighting geometry, light reflected from dust is not polarized as it is in ordinary comets and asteroids. A minimum of about -2.7% and a narrow polarization curve profile is a combination that has not been seen before in any other body in the solar system. Interestingly, some distant small bodies like transneptunian objects and centaurs, bodies rich in ice and organic matter, have similar characteristics. This is an additional clue. 3I Atlas dust may be coated with complex organics formed by the same cosmic ray irradiation suggested by the chemical data. When you have an interstellar object, there are always those who wonder, what if it's not just a comet, but something man-made? It was like Oumuamua, it was like 3I Atlas. Adding further fuel to the fire was the fact that the Meerkat radio telescope in South Africa has for the first time caught a radio signal from an interstellar comet. Words like first radio signal from an alien object immediately popped up in the news headlines, and you could go on without reading to make up a story about aliens. But the real data turned out to be much more mundane and, frankly, more interesting. The signal was linked to the characteristic lines of hydroxyl OH, the same one produced when water molecules are broken down by solar radiation. We observe almost the same type of radio wave emission in ordinary comets in our system. No modular structure, repetitive messages, or mysterious frequencies. Everything that astronomers have seen fits within the framework of normal chemistry and physics. Nevertheless, individual scientists, including the well-known lover of bold hypotheses, Avi Loeb, continued to discuss the possibility of an artificial nature of the object, drawing attention to its unusual resilience and some strange features of the tail and anti-tail. But most experts agree that anomalies can be explained by a combination of composition, rotation, shape, and mass loss, without resorting to the idea of an alien probe. The orbit of 3I Atlas is tilted and retrograde. It flies against the wool relative to the general direction of the planet's rotation around the Sun. The speed is more than 130,000 kilometers per hour relative to the Sun. It's not just a space pebble, but a full-fledged interstellar projectile. In the fall of 2025, the comet passed relatively close to Mars, tens of millions of kilometers. It was then that vehicles like MAVEN and even the Perseverance rover managed to take their pictures. In them, 3I Atlas looks like a small blurry speck against the background of the stars, but for science, these shots are invaluable. They allow you to measure the brightness, the shape of the coma, the direction of gas and dust emissions. On October 29, 2025, the comet passed perihelion, the closest point to the Sun in its orbit. At that point, it was particularly active in losing mass. The ice was evaporating, tons of dust and gas were carried into space every second. But, and this is important, it didn't fall apart. Some expected that such a fragile interstellar visitor simply could not withstand the solar heating. But 3I Atlas survived the encounter with the Sun as a sturdy, monolithic object, although it was badly burned from the outside. Now the comet is already moving away from the Sun, having passed through the inner system, and is gradually dimming. In mid-December, it will approach Earth at its closest distance, about 0.0018 astronomical units from Mars before and roughly 167 million miles from Earth, far enough to pose no threat, but close enough to observe it through telescopes a little longer. In a few months, 3I Atlas will become too dim for even the largest telescopes. It will go back into the depths of the galaxy, possibly to meet new star systems, where no one will ever know that once this piece of ice and rock flew through ours. But her brief visit has already left a mark on science. We received the first detailed chemical portrait of an interstellar comet with such rich data, the first recorded radio signal from an interstellar object's coma, completely new dust and polarization signature, strong arguments that cosmic rays are seriously finishing interstellar bodies. Somewhere now, at this moment, millions of similar comets are flying across the galaxy. Most of them will never cross our orbit. But 3I Atlas has shown that if we manage to turn our armada of eyes in its direction in time, the universe is ready to reveal something about itself. And maybe the next time the sky gives us an interstellar visitor again, we'll be even better prepared with new telescopes, bolder ideas, and even more questions. Because every object like this is like a letter from another star system. And our challenge is to learn to read these letters without fantasizing about dishes and signals, but with respect for how different the worlds around other suns can be.